this is the Kinect camera. This camera looks at all these boxes and searches for the item, right? And if it finds, picks it up and puts in the delivery box. So this is an setup. This particular robot went and participated in Amazon Robotics Challenge that was held in Leipzig, Germany. You'll see another robot also that participated in the next version next year in Japan. So what you see here, whatever is okay. Before I start, I normally ask questions. That's my natural way. Suppose this, you go to a grocery store with a list, right? And you give that list to the shopkeeper, and shopkeeper searches for the objects or items that are there in your list and brings it, right? Same thing this robot is doing. Not only that, they are all in practice. Last year Alibaba had a one-day bonanza where they use many thousands of robots, because some millions of orders came, and they use robots to do this. So now the question here is, instead of a human, we are using robot. So is there any difference between a human and a robot? What is your answer? अरे emotion भी हो जाएगा. We conducted one Roman. Srikant is here, right? We brought Sophia, right? अरे Vishnu is here. So emotion भी हो जाएगा. Those are not issues. Anybody? In fact, there was a conference, school principals conference in Dehradun, and because I'm running also a school, they invited me to speak on AI, because government of India now wants to take AI to the schools, 8th standard, 9th standard, and so forth. I asked the same question, and there was a Professor Ganguly. He is actually CBSE director. He answered, there is no difference. There is no difference between the human and the robot. What do you people think? Okay, so you will not be able to answer because you don't do work on this. It's not a very easy question to answer. But what is strong AI? A machine with artificial consciousness. That means when it does things, it should be able to feel that it has an identity. All right? Now, this is a question that we always ask. Nobody asks these questions, right? What makes me to learn? Like suppose many of you come and you get admission in SIT. Some of you learn, most of you don't learn. Right? Why? What makes you learn? So many people want to become a sports person. Very few learn, and majority don't learn. They simply, they do pattern matching. Okay, if I remember these things, vomit in the exam, I get a degree, right? This is called patterns. So basically, even most of the human beings in the current globe, out of 7 billion, I would say it will cross 6 billion who are simply pattern makers, like robots. So that's a completely different topic. I won't enter that, but that's a dangerous thing. Being human means to be conscious. So the thing that you saw, I will show you so many research areas involved in that. Okay, so this is my robot system with the camera and everything here. The vision system collects the frame-wise data, then object detection localization, and simply Suppose there is an object and you want to pick it. This is called pose. Okay? Pose means you go to a place where you close your finger, right? And camera is dealing with 2D. Objects are not in 3D. When you look at camera, it's all 2D frames, right? So pose estimation is another research issue. So normally we make from 2D. Once you understand this is the object you have to pick, then you have to make a 3D model, or using simply, we said 2D half model. That means using cloud data and 2D, you can have an approximate pose estimation position. And once you know this is where your robot will go and your arm is here, how it goes from here to here. There can be obstacles and so many other things possibly, and there can be singularity, means in this path there are points where robot cannot reach. So there are so many things, you know. This requires, of course, idea about a robot, and so that's called inverse kinematic solution, right? And inverse kinematic solution, but then you can from beginning point to end point, if you give a inverse kinematic solution, then what will happen that you will not be able to avoid the obstacles, or certain paths you are forbidden. So that's why inverse kinematic solutions always is employed point wise. That means you, from this point to pose, you make waypoints, and these waypoints are given different ways. One of the ways that has been done in this particular demonstration that you saw is called DMP. That's what I'm supposed to speak, but you know, any topic you go very deep, it becomes very highly mathematical, but I will try to show some of these things. So DMP means dynamic moment primitive imitation learning. You do that, or you learn it from programming, from demonstration. In fact, nowadays the popular note, earlier the robots were confined only to the industry shop floor, so in a case, but now robots are coming and living among the humans. So you have to have an interactive communication between robot and humans, and so that's why the robots must be able to function with minimum programming, that is called hard code programming. So people should simply teaching the robot should learn. That means there is a framework in which robot can learn certain things on its own, and the user doesn't have to know how to program the robot. So this is called imitation learning, and there are various of models, mixtures of primitives, and these are all scientific. See, you see, all these topics are all research topics. They are not finished. Okay, every day, every time there are papers coming, and then finally, because robot is a dynamic system, you have to ensure stability. Okay, so there has to be, whether you reach this pose exactly or not, how do you know? So there has to be a closed loop. Loop, and this is called the control. This is actually the area in which I started, but then once you work in robotics, you have to traverse all these areas. Okay, so this is the whole thing involved in that demonstration. Just to give you how this happens, this is a setup in my lab where you see this is a robot. These are the cameras. Cameras can be also mounted on the thing. This is 7 degree, you know. Why 7 degree? Because anybody who knows why 7 degree? We can have 2 degree, 3 degree, 4 degree, 5 degree, 6 degree, more than 7 degree also. Our hand has 7 degree. You understand what is degree? You see, this is 1 degree. This is another degree, right? So similarly, from here to wrist, there are 7 degrees. You see, this is another degree. So why 7 degree? 7 degree means you make a robot redundant. What is meaning of redundancy? Any object I have to manipulate, it is in XYZ. That means you should be able to, your end effector should be able to manipulate object in XYZ environment. And plus pitch. This is yaw, and this is roll. Yaw, pitch, roll, right? So this is 6 degree. So once you add 1 more degree exactly, it becomes redundant. Means to reach the same position, you can have infinite solutions, theoretically. For example, I have to touch my nose. How do I touch? This is one kinematic configuration. From here, like this. This is another. I can touch like this. I can touch like this. I can touch like this. I can touch like this also. You see? So this is the idea. Means redundancy means you have many possibilities, but you select just one of them. Okay. So like for example, I normally touch like this. You know why? Can anybody say? When you touch your nose like this, why you touch like this? Why not like this? You will see that you feel you have minimum effort here. So normally you select, or we humans, we learn where is my effort is minimum, right? So I'll tell something interesting, because remember the question that I asked you, whether the robot is equivalent to human. Okay, whatever we do, once a robot does it, can we say robot and human are equivalent? So, oh, this is a laser pointer. Okay, so I picked up to show you an object. Okay, so this is the robot, and you see, just like, you know, we don't move our tip. You must know that we make the manipulation in the joint, and tip moves, right? So this tip here, which moves in the Cartesian space because of the joint motion here. Okay, so like theta 1, theta 2, 3, 4, 5, 6, 7. So there are 7 joints, and this motion in joint space causes the motion in the Cartesian space. This is captured by this equation. Motion in the Cartesian space, motion in the joint space is related by a Jacobian, and this Jacobian you can easily see here. X is 3 by 1, XYZ, and theta is 7 cross 1. Obviously, this is 3 cross 7. Right? This is a rectangular matrix. And every element, because it's a 7D of manipulator, every element in that J is very long as well as highly nonlinear. Terms like cos theta 1, theta 2. Yeah, thank you. Yeah. So, and when this is moving, the tip is moving, then this pixels in this, they are also moving. So the motion in the pixels and motion in the tip or Cartesian position, they are related by L. This is called image Jacobian. And this image Jacobian normally you can derive using camera models and other parameters involved. You combine these two, then the joint motion and the pixel motion or image motion, they are combined together through the product of two matrices L and J. The idea is that I have to find out theta dot. This is my controller. This is my desired pose or desired visual feature, and this is the controller. This is my robot. This is a camera, and this is a feedback, right? So this is a close. So you set up an error corrector here, so that you ensure things are moving. So Just to, because there are so many works are there, I'll just explain to you one simple example. This is called adaptive distributed fuzzy PD controller. So I have to now design a controller, right? So that robot goes and catches the object or follows an object depending on what is the task you give. So these are all visual features, and these visual features have been fuzzified. So what happens actually, suppose this is a robot sitting here, this is a workspace. And in this workspace, because the robot kinematic control is highly nonlinear, you cannot have a single PD controller and it will be able to exactly control in every corner of the workspace. So workspace is discretized. Okay, so this is one zone, this is another zone, this is another zone, right? So you create a sphere, cell, right? Small sphere, and assume within every sphere, you know, that you have a one PD controller. And that spheres are generated using fuzzy logic, right? Of course, there are so many other ways you can generate. You can generate also hard cells using KSOM. There are so many ways we have done this work, but that's not important. You can easily see here proportional gain into error, derivative gain into change in error. What happened? ठीक है. Okay. So so you get every zone. Let us say there is n number of zones, and each zone is giving certain output, and then you fuzzy average of all these decisions. Now you don't have a single controller, you have multiple controllers, and you have to learn the way of fuzzy averaging, and then you get an output. But the idea is that I don't know what is P and what is D. You know, all of you who are all students and teachers, you have done control system. Everybody does control system course. So for linear system, you use root locus approach, Bode plot approach to design proportional gain, derivative gain. This is a nonlinear system. You don't have those techniques to do here. So how do you do it? So normally we use nonlinear control theory. So this is a Lyapunov function. What is a Lyapunov function? Lyapunov function is, imagine, because what I'm trying to do is that this minus this error has to be minimized, right? So error minimization is a simple concept. Suppose I move from here to here, my rate of change of energy should decrease. Then error will decrease. If my change in energy is increasing, then this error will increase. It's a simple concept of Lyapunov stability theory, right? And this exactly, so this is what, you know, this is a student from Indonesia, Indrasno. So he saw that this is the function that really satisfies that criteria. And then you have to take this energy rate of change, that is, you differentiate this with respect to time. So this is the quantity, and this would come like this. Now what to do next? In fact, when I was sitting in my chamber, he came with this expression exactly and told, sir, I'm stuck. So then I told him, just sit there. Almost it took me more than half an hour or 1 hour to use some of my, you know, whatever my background intelligence, intuition and everything. And then this P dot and D dot, I suggested him by some iterative intuition, this should be P dot and this should be D dot. Okay. How this came? So, but this is, you don't have to worry. But this is what, once I said that this would work, I told him, please go back. Please place P dot here, D dot there, and then show me V dot is negative definite. After another 1 hour, he came back and told, yes, it is. And then Epipure, right? So you see, this is the 5-hour digital camera. This is the ping ball. And this robot has to follow this ping ball while maintaining a fixed distance between the ping ball and the end effector, right? So when I told you what is the difference between a robot and a human being, I hope you understood. Is that, did you get it? This robot didn't do. Neither robot did do this. Nor robot understand all these intermediate processes. Robot, these two equations have been hard coded. This is hard coded. Okay. So now question is that how do you get this? So now, okay, I got it because, okay, we are able to do it. Robot is not able to do it. But imagine Maradona, he understands all these equations. Sachin Tendulkar, I think he's a school dropout, right? Does he understand all these things? Without mathematics, they do it. That means the way humans do, we don't know. But when we try to solve the problem, we have to go through very, very severe, school. Like, you have to come to SIT, grilled here 4 years, and then go to master's, grilled there, and then again PhD. And after that, you'll be able to think like this. Okay? So there are two things. One is, yes, all these things we do, robot is simply hard programmed. So robot is far from the humans. But the humans, the naturalized way of learning of humans doesn't involve mathematics, let me tell you. Okay, so what is that? So that's what, I was telling, I think Samir, I told just now. I was giving this talk, how to build a machine that will have consciousness. So that's a completely different topic. So this is another, the second year challenge we had in Amazon Robotics. And the challenge is, this is a robot we carried to Nagoya, Japan. And the problem was, they gave us 40 daily used items like toothbrush, the liquid detergent, everything that we normally use, 40 objects they gave us. But then they told us when we reach the event venue, before our team competition starts, just 45 minutes before, they will give 50% of objects to be unknown. Unknown objects, 50%. So you will see in this video, preceding this video, that there are 32 objects, 16 are from these 40 objects they have already given a priori, and 16 later, there, then and there. So we have to solve this problem. And there are so many challenges to solve this here. I'm not going to give on detail of this, just to tell you what happens. See, this is a tote. All these objects are cluttered there, right? And see, and the organizers, they knowingly, every time they shuffle it, so that our algorithm should be able to do it in any situation. So this is not a, and of course, this is our customized algorithm. In fact, it turned out among top 16 teams finally entered into final, our algorithm was the best. We are not good in terms of hardware, but software was best. So what is this? This is your frame, the camera text. This is a 2D frame, and it has to categorize. So this learning algorithm categorize. This is a deep learning algorithm. This is categorized. So this is an object. So it will create a contour. If it knows this is one object, so it will create a contour, just like you see here, right? Similarly, this is another object here. So around this will create a contour, the way you are seeing that, right? So this is exactly our deep learning algorithm. It did it. So this is a PSP net with 50 layers. 50 layers. In fact, to execute this learning algorithm, we carried a 8 GPU server, and that 8 GPU server was simply meant for this object recognition. So this is simply different results, right? So this is this is a robot. Normally, transparent objects are very tough to determine, but you can see here. Okay, so these are two different algorithms. Simply, so you see here, the existing PSP net took normally, which was there, 6 hours it takes for training. But as you know that we are given only 45 minutes. Out of 45 minutes, the unknown objects, you have to take the snapshots and then you have to train. But fortunately, the customized net that took only 27 minutes, right, for training. So that was the USP of our approach. And I think this is the, let me go through this video. Will just give you little idea. This is also the same work got published in ICRA. This is, I think this is, I have to move like this probably. So you see here, this was the setup we took. This once you place a object here, then this will rotate. And these are the cameras. And they take multiple snapshots, right? Because when an object is cluttered, its orientation can be different. From different angle, the object image will be there. So you have to have as many image snapshots of that object. So this was the so this is the mask and box leveling. This is the idea here is, okay, let me first show you the video. I'll just tell you how did he, collected the real-time data. So this is our robot. So it has been given 10 objects to be picked from 32 objects. Out of 32, there are 16 new, 16 old. But because there are new and old, we have already trained over old. And over that, if you train the new, we found out the network is forgetting the old. So it was no use for us training a priori. So we trained everything together there, right? And so you can see here, in fact, our robot could pick out of 9 objects in 7 minutes, less than 7 minutes actually. Total time was 15 minutes, and still 80 minutes are there, and we saw our robot stand still. I said, what happened? Why it is not picking the 10th object? And then we realized, one of the students, Prabhu, because our hardware is not strong, there are certain objects our robot could not have picked. So he was testing an algorithm called persona non grata, object non grata. That means if this object would come, then you don't catch it. Just bypass it. Go to the next item in the list. And that simple object, which was the 10th object, he had put it in the object non grata. And that's the reason our team became third in the competition. But the interesting here is that you have all these, hues, around 6,000 images, and all these images what my student did is that he wrote an algorithm by which automatically in a the tote you can put them, throw them, and every time synthetically you are generating one clutter, right? And then you created a lot of training data. This is all happening. See, this is something to be told, because as the images are being taken from that rotating platform, so there is automatic cluttering is also happening, and that's how he actually minimized. Within 45 minutes time was given, we are ready almost before 40 minutes. So that's how the whole thing was there. Okay, so as I told you, so many research challenges. I will only focus on the DMP part. What is imitation? Imagine a robot has to learn a dance from a teacher, right? So as I told you, majority of the dancers, suppose I have three daughters. And I sent them to a dance teacher, and they were robots. So all that they will learn is the pattern. You become a dancer when you are conscious. That means you have creativity in dancing. After some time, I told three of my daughters, dance is not for three of you. Stop it. Because majority, it's like same thing, science. Everybody says we can do science. But after some time, when you do science, it's not science for you. It's a pattern. And we are all doing patterns. And hence, things are very boring. Unless whatever you are doing enters into your conscious space, that means you and your activity are non-different, then you really enjoy. This is what is interesting. I mean, this is what the revolution we have to do in our education. And this is the reason I started our Gurukula, where we don't tell our students that you have to learn this, learn this, learn this. We have sports, we have science, we have varieties of activities, from cow rearing to making low-cost house, brick, mud brick, all possibilities are there. And we throw our children there, you do whatever you want. And we have a monitoring mechanism, and we see where is his consciousness. And this is something missing in our education pattern. I'm telling because, whatever we are doing, we realize. So this is all, whatever AI is doing currently is all pattern. It has no consciousness. Soul is missing. It's not that AI has become, now everybody is now talking AI. AI started long back, in 54 first, Minsky coined the word AI. And since then, it became dead almost in the middle of the 70s. And again, with the neural network in the late 90s, again, the topic came out. And by the time I joined in BITS Palani, by that time it was slowly having its death. And suddenly, this Hinton, started as a deep belief network. In 2005, again, it is becoming hit. And then the GPU and all things came, and then suddenly everybody is talking about AI. But whatever it is, the soul is still missing in AI consciousness. That's something that we have to learn. So I will tell you how this is a pattern matching. So this Kathak dance, what is happening? The Kathak dance is being converted into primitives. So like bandhana, that, salami. If you are a Kathak expert, you will know. Just like, suppose you are a classical musician, a raga. So raga is a different ordering of notes. There are 12 notes ordering. So they look at the pattern of this note, and then they say this is this raga, this is this raga, right? And similarly, You visually, by auditory means, different way, when the teacher is performing, you extract those movement primitives, and then you have an AI algorithm to create a sequence, right? Output them into a particular pattern. And based on that, the joints of the robots are synchronized with these movement primitives. It's simply, you transfer the pattern to the pattern of the robot. Just to demonstrate here, so this is the demo. This is Samrat, who is now in TCS. So you see, he gives a demo to the robot how to pick the bottle and will put it in the box. Right, this is demo. And then robot now comes himself, picks it and puts it there. Now imagine if there are more objects on the table, you have more demo, then how do you handle? So that requires certain science, right? I'll even go to a little more tougher proposition. So this is demo. And you see that this ball is coming from all directions because it's a freely hanging. It can come from any direction. And once you get the data, you put in a learning framework and teach the robot how to go there and hit it, right? So you see here, so this doesn't do a good job. Why? Because it requires more examples. So you see that all the time it middles the ball, all right? So here, this looks to be very simple demo. A lot of work has to be done because the ball comes from all directions. The visual tracking has to be done properly. Once tracking is there, there is a learning framework, and that learning framework, tells the robot where this particular bat should come exactly to hit the ball. Okay, and just to show you a little, sometime it is good to show. This is exactly the dynamic system model in which the data, all these examples were given. All those data were modeled in this expression, where this is an unknown parameter, this is another unknown parameter, this is another unknown parameter. They have to be trained. And not only that, because this is a dynamic system, you have to make this system always, whenever you train the data, this model should be a stable model. For that, this UK has to be learned. And for that, you have a model of UK, there's a Lyapunov function, and based on that, you exactly compute what should be this parameter and should be this parameter. So all these details has to be worked out before this works. Okay, so this for everything, all this math you see, imagine you ask Maradona that only if you can learn this, then you can play football. So you won't see any soccer game. Okay, so this is what is human consciousness. So this is the point. Recently, MIT invited a series of people who are good at consciousness, because Western people, they cannot know consciousness. You know why? I hope that you will not feel offended, because once you eat meat, you cannot understand what is consciousness. It's a fact. To be able to understand consciousness, you have to become non-violent in your food habit. Okay, so you want to understand what is consciousness, first go vegetarian. I'll tell you a story now. Recently, you must be knowing that you can go to the YouTube, Google, you will find this. United Nations employed around 90 big scientists, and they have written a big paper, huge paper, and they said, if you want this world to survive, then go vegetarian. Yeah, go vegetarian. And just to let you know, just like I recited some slokas here during the lighting ceremony, we conducted this romance in Le Meridian in Delhi. In fact, we brought that conference for the first time. You were there in the inauguration? Yeah. So I made everyone to stand up. Here, the moment I recited, all of you stood up naturally. But there I have to tell them that you please stand up. And then I recited verses, right? And after that, what happened, something, many people, because, I normally, I keep a very low profile. There are many reasons to maintain that. But many of them, because, in that conference, majority were foreigners, and they said, we were really impressed by that sloka recitation. So after that, I went to IROS in Macau. So one of the keynote speaker, Richard Alamy from France, he was also there. So when he saw me, oh, I enjoyed your verse recitation, right? I said, you people have to learn a lot from India. And he was completely, so what do you have to learn? So one thing I said that you have to learn that you should go become vegetarian. So then he was simply surprised how this is connected. Then he told, my son has become now vegetarian, and he argues me that I must become a vegetarian. And then when I don't agree, he says, don't worry. Nature will force you to become vegetarian. So actually, to become a conscious, you have to be absolutely non-violent in every aspect, not only food, all aspects. And nowadays, you see, there is a lot of rape incident, right? This is also violence. So all kind of violences must stop before you can enter into what you are. That is, you are a conscious being. Then you can see yourself, and then you can see how consciousness produces everything wonderful. And that is the beauty of this India that can teach. So, okay, now this part will be very tough. Should I continue this part? How much time I have? Saroj? Almost time. So, no, don't worry. See, this is very technical. This is very technical. I will, in fact, I'll just give you an idea, because my students are building a platform by which this robot, you saw a robot can hit the ball, but now it has to play tennis with the opponent. Okay, so how that happens? So this is the person, the player. So this you have to set up that what is that called? This as a sleeping time. So okay, so you see here, this is the robot, and it has to play tennis with this. So this is the complete framework. This isn't. It takes certain action. What is action? It hits the ball, right? Then when it hits the ball and in the area, somewhere it will hit. And based on that, states change. And the states are rally. You hit, he returns, you hit, he returns. Okay. And who fails? You failed or the other person failed? What is the number of rallies? So based on that, you get certain reward, right? And this has been, so this is called higher level planning. I showed you what is lower level, right? That hitting is a lower level. and making a complete plan because you have to defeat the opponent. This is called higher level skill. I think because given the time, so these are all details. You see here, this is the plane in which the robot will come and hit the ball. And these are the actions that it can hit here, it can hit here, and all these places it can hit. Suppose the player is here, so robot must learn to hit this place, not here. Because if he hits here, then player will return. If the player is this side, robot must learn to hit here. You see? So these are the things that, and so once you enter into this, by reductionist approach you can do. And reductionism brings us to mathematics and physics. You remove reductionism, the physicists, they will be jobless, mathematicians will be jobless, and many people will become jobless. Let me tell you, when people become conscious, many jobs will simply go away, vanish. Okay, so this is something people have to understand. These are all details. This is what actually I intended to speak. These are all very mathematics. I will stop here. I think given the time, I probably will show you a small video here. If it is there, yes. This is Ravi is still PhD. He's about to finish. The same thing. Only the lower skill, but here he doesn't have to depend on many examples. So he hit the ball and then made the robot how to withdraw the arm to its home position. And so this is one complete trajectory, and then you have multiple, around maximum 10 examples, 10 demo. And after that, robot learns how to hit. So this is a more advanced algorithm. See, research is something, you must show that you are better than the contemporary people who are working. And then your paper will be published. Once your paper is published, hippie pure, right? This is what is the research. Okay, so this higher level, this is I think I should go. This is what you see here. This is our proposed approach. You can see here this blue line. This is the number of rallies, right? Over the every time you serve, how many rallies will be there? So you can see the number of rallies are going down. That means robot is learning how to play tennis, right? And you can see there is a border. What is meaning of this border is that this is a probabilistic, in the sense that every time you hit, it is not certain that every time you will have the same number of rallies. You rerun it, right? So over 100 runs, you make the average. So this is the minimum and this is the maximum. And this blue line is the medium or average of that. So this is okay. So I will stop here describing this hard problem of AI, and this should tell you what is the difference between a human and a robot. In fact, when there was a Taros conference in UK, in fact, we organized when I was in Ulster. So they asked me, you define from your research a thought experiment that would tell that this is a hard AI, right? We talked about weak AI and hard AI. So this is what I told them. That your robot comes to your house, hears your family members, picks up vocabulary slowly and steadily, starts speaking in a broken language, and becomes expert in your language, learns to write poetry, and receives a Nobel Prize in literature. Right? So this is where, nowadays, this pattern matching has really destroyed our population. Rote learning, formula, some pattern you have to, and particularly nowadays for JE you must go to a coaching. It's all pattern. It's all pattern. And if they were so good, once they enter into IIT, they get 4 point, 3.5, 3-4 termination notice. You can see, I don't go to CNET nowadays because I get really, psych when I see, the same student has applied now 3rd time against his termination notice. Because you made him pattern before he entered into IIT. What you will do? Okay. So, okay, I think these are all some details. In spite of tremendous progress in AI, deep learning, all AI machines are syntactic machines. Our interpretation makes their output meaningful. Semantic machines researchers talk about, but I have not seen anyone really working on it because they don't understand what is consciousness. Consciousness has many layers: physical, mental, intellectual, reflected, pure, and pure. Let's talk about the consciousness in the physical layer. We don't have to go to the yogi's stature where they talk about this too. We don't even know what is consciousness is a physical layer. You understand what is consciousness in physical layer? You say you hit it, it doesn't talk, doesn't complain. But you hit here. If you come and hit me like this, I'll also hit you, right? So this is called consciousness and physical layer. Okay, and beyond that consciousness in mental layer. When you become Premchand or Gothe, then consciousness in intellectual layer. You become Einstein or somebody like that. And then you go consciousness, qua-consciousness. This is all in a different level. I think I should stop here. Thank you very much for your present hearing. Who wants to have some 1 or 2 questions? I think Saroj, you have to meet someone. Right? You don't have any questions? Then I will start asking questions. Yes. How many of you have the background on robotics? And IoT? AI? So you have to take steps to learn. Yeah. So there are no questions, then we can end up. Okay. Thank you very much.
Just 5 minutes. She's going to get a little.
Okay. Yeah, saying this is our robot getting ready for our competition in 2020 in Abu Dhabi. This robot will make challenge is to make a brick wall. So in 20 minutes, it has to raise.
The next speaker with us is Mr. Srikant Modugula. He is the co-founder and CEO of Civia, a specialist in VLSI, system design and B2B solutions. Civia serves clients in India, Europe and the USA, including some Fortune 500 firms. Now, he is nurturing two promising B2B product startups, Games to Hire and Grinces at Civia. Prior to becoming an entrepreneur, he served as an entrepreneur in the capacity of director at AMG Building and operationalizing a team in India to design digital TV SoC and applications. Mr. Srikant joined STM Microelectronics in 1995. He spent 11 years there leading the activities of mobile multimedia platform, VLSI design flow, and IP reuse in India. The shining alumnus of BITS Pilani, Mr. Srikant holds a bachelor's degree in electrical and electronics engineering and cherished a master's degree in mathematics. He takes pride in grooming hundreds of successful engineers and tens of productive project teams in the last 24 plus years. Today, he is here with us to enlighten us on current market trends on VLSI design verification embedded systems. I welcome you, sir.
Can I bring it up? Disconnect. Yeah. Yeah. Hello. Good afternoon. So I was just in the lunch. I was asking, how's the sessions? What are the things you're looking for? So thanks for so many very nice, stuff spoken from the morning. We have seen what and all is possible, right? What and all is possible, what can be done, what more can be done. First of all, thanks for, Dr. Behera being here. I just finished in 95. I think Sir joined just in 95. I missed to be taught by him, but he's representing all our, the good fortune we had in Pilani. I can remember said there are a few things, because we just talked about consciousness and understanding patterns. The robots see patterns and they just imitate pattern, right? They can't do more than that. Maybe within a very fixed algorithm, they can move and they can do things. God has given us a special gift that we can see pattern and we can interpolate, extrapolate. We can do things which probably even we thought we could not do. Yesterday we would have thought, no, we cannot do that. Today, with our new consciousness and learning and thought, we are able to do it. Just like the footballers or cricketers, nobody is born footballer, nobody is born cricketer, nobody is born singer, right? So what I can share with, let's, even though I prepared for it, whatever, what I thought was seeing the flow. I'm also improvising. From the morning I'm seeing and, what can be done in my session. I'll give you certain instances of things. Because how many of you are sitting here just to be in the workshop, probably for a certificate? Or how many of you are sitting here thinking this is an investment? All of us have limited life, right? We're all human, we're all mortals, and this is one day in our life, correct? Do we recognize that? It's one full day, no? And it's going to be 3 more days, 4 days of your life you are spending in NES 2019. So do you want something out of it? Can you raise the hand who wants something out of this 4 days in your life? Right? So all of us want something out of our life, right? This is what life is about. So I'll give you certain things from which you extrapolate, interpolate, use your consciousness, And as we go forward, there's a panel discussion, there's a interactive session, there are tutorials and workshops. So I encourage you to think and maximize your return on this investment of these 4 days of your time, all our time, right? So one is when I was talking about BITS Pilani, just the way of learning, how it happens. Just think sometimes, how do we learn? Do we learn from only one way, two-way, multi-way? How does it work? Dr. L.K. Maheshwari, so he was our vice chancellor also. So when me and one more friend, after finishing our compulsory courses in electronics, he used to teach us electronic devices and analog electronics. So we wanted to do this VLSI design. I don't know how even we picked up this buzzword, because we didn't know anybody who was working in VLSI industry, or we had no internet, we had no Google, nothing was there. Somehow me and one friend thought, no, we should learn VLSI design. So we went to him, then, sir, we want to learn design. So he said, beta, I don't teach design and all, I teach devices. But we went again, sir, we want to learn, how do we do it? So then finally what he told, he told, okay, you learn and I will listen to you what you are learning and give you my advice on what to do differently. So M24, so me and Paul, my friend Paul Satya, both of us, used to stand like this, because 2 people learning, both every week we come and present for half an hour. Sir alone is sitting there and Paknal and Esra again, he told, okay, we'll buy a nice book. So he told Paknal and Esra again, buy the CMOS VLSI design, and we did chapter by chapter. Can you believe it? And our job in ST Microelectronics, when we went for the interview, first Paul went for the interview. First he was rejected at the gate itself. When he went inside the reception, HR person told, hey, what is your background? He said, I'm a BTech from BITS Pilani. So he said, no, we don't take BE people. We take only ME Microelectronics. You go to Siri Pilani and BITS Pilani, do ME Micro, then we'll interview you 2 years later. So, but those of you, very few know, I think, you know Paul? No, you don't know. Paul is one of the most stubborn characters I ever met in my life. So he kept 2 times, 3 times. He said, no, this is, this is not correct. You should interview and reject me. On degree basis, how can you say you cannot interview? You know Paul also. I think you met Paul, no? So then finally they agreed and they said they'll interview. Even now, Anand Hardy, who is the ARM center head in Noida, even now Anand keeps saying, Srikant, that day Paul came with 10 sketch pens. He went to the interview with 10 sketch pens because all we knew is Paknal and Esra again, how to draw stick diagrams. We never used a layout tool because we just did stick diagrams on paper. So he took these 10 sketch pens because he was prepared to draw in color. So, but they had nice fun. They made him talk for 1 hour, 2 hours. Then he got the job. Then I went. Then they said, oh, you are from the same batch. Can you tell entire Paknal Esra again? I said, yeah, well, very nice. I took the book also with me. So I kept the book on the, so first Sandeep Sethi came, who is one of the, and then Vivek Sharma came, who is, country head. So all of these people were very surprised. Oh, how you know? So this is thanks to our Dr. Maheshwari, we learned this. So again, I'm purposefully not making any judgments or any gyan to tell you do this, do that. Just observe the things and figure out what could be your return on investment, right? You could make out from this story what was our investment and what is our return on investment. We were the first few BTechs in the entire ST Microelectronics batch there. Right? So then I'll tell you one more story. Sir did not tell. I don't know, maybe he was too modest to tell. So sometimes you have to see things in a context. Then only you will understand what is actually happened. This is like Ramanujan. You can say, okay, Ramanujan, great mathematician. That in French we had, in the UK we have all this. But you have to see Ramanujan in what conditions he did what he has done. So similarly, what he was showing those videos of the Amazon picker challenge, right? Just can anybody guess how many teams competed in that event overall? Amazon Pick and Challenge is probably the gold standard in that event. There are many other challenges in that event called RoboCup. Just take a guess. Some of you know, so you don't. So just guess how many teams would have participated. Take a guess. No, nothing wrong. At lunch, we are freely talking. We can talk like that. What do you think? How many teams participated? Maybe 1,000 plus. If you talk all the leagues, all the things. So how many countries? Yeah, a few dozens, maybe even 30, 40, maybe more, right? Indian population, you know, how much is our population? So what is the globe's population? So we are almost 1/6 of the entire globe, right? So how many teams you expect? The truth is, if you leave the children's teams, I went with my children that time. That's why I actually saw that robot. I saw the event. I saw the robot. I didn't meet them. I met one of his students. They were so busy in their, making it do all those challenges. There was nobody other than their team, except the children's teams, which were also probably, we went, right, from junior category. So we went, I think 4 teams went, 4 or 5. These are all high school children. Anybody other, even high school is very low. Imagine 5 teams. We're talking about 1,000 teams. High school and above, how many teams? 1 team. And they won 3rd prize in that. You know the competition, whom they had? He's too modest. He won't tell such things because he's, I think, sir, the CMU and Princeton had a combined team, right? Which one? MIT and Princeton. MIT and Princeton had a combined team. One team composed of some MIT people. You heard of MIT? No? Not Mangalore Institute of Technology, right? Manipal Institute of Technology. No. This is the real MIT. Right? And Princeton. And then NTU had one. And then I think you had a Japanese team from U Tokyo and Nara, I think, combination, right? Nice. So this is the best you can think in terms of the rankings, what you see, and even Mr. Modi is nowadays feeling, rank bada do. Rank is a thodi bad jata, right? If it is, everything can grow because of slogans, it cannot, right? It is, now you understand the achievement they have there, right? So let's give a big hand to their, it is not at all easy because you have to be in the, as I said, you have to see things in a context and a community, because I'm part of that. I know what goes on. That is like somebody whose village even doesn't have PhDs, and that village, somebody has won Nobel Prize. Imagine if that is the level of this thing. So how could they do it? What is special? Truly, do you think real? Of course, there is a team, there is IIT, JEE, all that. But do you think really people with 4 legs only go through IIT, JEE and come out? No, no. Right? So what is it specially being done there? So that is, let us identify what are the things we can do being engineers. Now, whether we like it or not, we are become engineering BTech 3rd year, 4th year, right? Correct? So there are stuff which one can do, and one can really excel in what is chosen as a discipline. So if you see today, there are some fundamental things which got changed. Look at their own achievement. You would have probably needed a 100 researcher, 5 laboratories, $100 million fund to do the same sometime back. Now he told he has run that 50 what do you call, sir? CNN 50 layers. 50 layers on 8 graphic cards. So 8 graphic cards are probably few lakh rupees. That's what it is. But in the past, people had to have supercomputers and very extremely expensive equipment to do research. So within few lakh rupees, they're able to design an algorithm and compete with teams probably which have probably morning I was listening. Recently, the IBM opened a AI center 1 year back in MIT. Just guess how much is the money they have written on the check. Just take a guess. One lab IBM has opened, one MOU. Guess the money involved. Dollars, mein. $250 million. $250 million multiply by 7 crores. That you will get crore rupees. So, but how they are able to win against the MIT Princeton team? What is the enabler? So things have changed in the industry. You can do things with less resources, both in hardware development and software development, system development, algorithm design, and beat the best in the places of their choice or anybody else's choice. You went to Nagoya. Did you choose Nagoya? No, right? Nagoya event happened. We went with our suitcases full of equipment and laptop full of code, and everybody goes there. And so if you have right preparation. So today the people in the lunch, they were asking, okay, sir, fine, these are all good stuff. So what do I do to be part of this journey? How can I get a job in whether it is digital VLSI design or analog VLSI design? We'll not go into the software part of it because most of the electronics people are sitting here, or the embedded systems or whatever. So how do I get a break? How do I prepare and get going, right? This is what you are asking. So there are multiple things you can learn about it. First one, what I'll use my talk is, there are things which you can actually do with all your whatever we are talking in SIT with your resources, and you can go and make products and really learn it for yourself, including the robot. What he has shown is much more complicated, but there are a lot of starting points in the robotics. You don't need to aim a Amazon picker challenge as a day one or year one challenge. There are many waypoints. Just the robo is trying to find its way, right? When it has a target, it is doing the path planning. Similarly, you can find your own path by choosing a point where you can reach and it's worth reaching, and from there you go to another place. This is the thing I have in mind. So let us make it a little interactive. So where are these embedded systems heading? By the way, one more thing I just want to tell. It may appear, vegetarian, non-vegetarian, these are beliefs, but there's a big scientific reasons nowadays happening. I'm a full disclosure, I eat non-vegetarian. Today, again, there was a interesting statement which is given by, I think people are all aware who are following climate change. Even if we optimize this lighting and power, the way we use the power, we reduce the wastage, what will be the big emissions where we cannot control? The emissions coming from the gases released by growing animals, which are mostly grown for eating the animals, right? In the farms where the cows are all there, big amount of emissions. Those cannot be controlled, no? Because we are growing the animals and eating them. So how can you not grow the animal and still eat it? It's impossible, right? So there is a huge interest to do research on non-animal meat. Basically meat which will probably taste like meat, but which is not coming from animal. I don't know, sir has to tell me, then the person who is eating meat thinking it's meat, but it's not meat, will he be able to maintain the consciousness or not? Because so this is what huge research and Bill and yeah. Okay. Okay, they're already doing that. So maybe. So there is a big funding happening from Gates Foundation, Bill and Melinda Gates Foundation, to people who are doing research in this non-animal based meat for the huge benefit of the entire earth, you know, because we can reduce emissions, we can save our climate, etc., etc. So they, apart from consciousness, there are clear and present dangers about not doing something about it. So here we are just seeing one, can you see from the rear, these are honeybees, right? You can see them, honeybees. So these honeybees are in a beehive, correct? There are beehives where these bees are kept and grown. One clear use of honeybees is what? To make honey. Very good. Anything else you think of? Okay, anything else? Big, much bigger use. Pollination. Huge business. Multi-$100 million business is pollination using the bees. These bees are transported across hundreds of miles in US, Europe, because at the time of season for pollination, the bees have to be available. So then they take the bees, leave there, and they pollinate. And this is a thorough research done by a friend of ours, Jay Prakash. I think you met Jay, Micron guy, the 88 batch guy. So he started a company in this space. And so how do you make sure that this investment is safe? The bees have to be in good health, and they have to be fed well. They have to, you know, go through their own life cycle correctly. They have to have proper temperature in their hive. Humidity should be there, and we should know when the bees are coming out of their cocoon. All these things have to be done. So people have developed these systems which are able to monitor the actual status of the beehive and inform the beekeepers what to do about it. So these are real things. People are making money on. So what do you think? These are the type of things I want us to think. What do you think will go into that system? Can somebody tell from the, let's guess, can be correct or wrong, right? Our MS Radhakrishnan, I don't know whether he left by the time you came, our mathematics professor. So he used to famously tell us only one bad answer can be given in a class. You know what is that? I don't know, correct. So you already attended MSR's class. So he used to tell this. The only bad answer can be I don't know. Everything else is good answer. So what do you think will go into that system? Please. Go ahead. Let's start with simple things, no? What do you think will go into that? Sensors, okay, good. What else? Transducers. What else? Processor. Communication system. Yeah, it has to tell us what is going on. Communication system. Computation system. Processor. So do you think that is simpler than this? A phone? Which is simple? That one or this one? No, that is simple. Right? The phone has much more complex components and software, etc. Because there the problem is very clear problem, right? You know what are the parameters to measure, and the amount of data you are transmitting is limited, and you can probably do it with very low power, and you can do it with wireless communication, etc., etc. So that is the components in this. So okay, next one is a little bit different, but that is, we cannot treat a robot as one embedded system, right? Because a robot is like a building, you know, like a human body with many systems. So this is the OSU's robot, which is trying to deliver packages. So this robot, how many embedded systems you think it has? You already saw many nice videos by Dr. Behera. No? So what are the things going into, let us say, a robot 7 degree of freedom arm we talked about? What are the things, components going in there? Tell us. What is there? How do you do this? Motor. What else? Microcontroller, controller. Anything else? Sir, what is the KUKA arm, sir? Nowadays, it can, when you tap, it will stop and all. Compliant arm. So compliant means baat suno arm, right? Hamara baat sun leta hai. You just tap it, it will stop. It is a heavy arm, you know. If it hits you, you are gone. So now they have a safety purpose. So those are sensors. The sensors are also built on the arm, and there are a variety of things, you know, the parameters it can, you know, touch, and any obstruction, etc. These can be sensed also. So similarly, the vision, we talked about Kinect camera, right? The Kinect camera has ST's imaging sensor in it, and that has again imager, processor, and some way to communicate through the, you know, most it's cable, it's not wireless. So there's a wired connection related circuitry, etc. So again, the question is that sensor or the arm itself, the arm, we're not talking about, you know, deep, you know, neural networks or CNNs, all these things. We're just talking about arm. So the arm, particular electronics involved in the arm, do you think that is reasonable compared to a phone or compared to your big laptop? Reasonable? Correct? So here you have another system which is from a Porsche research journal. I have taken this. So you can see here what is happening. The car is going, right? What is the car about to do? About to turn. So at the same time, there's somebody, cyclist is coming. So here the system is basically working on a camera which is identifying this is happening, and at the same time a car is also coming, and then the car is informed automatically that there is something going on, and the car is processing the information and telling that don't turn, stop. What is the benefit? Preventing accidents. So again, let us ask ourselves, how complex do you think the system involved here? There is a camera sensor, there is a, you know, processor which is transmitting the information to the cloud, and from the cloud, which is again, you know, it can be even local, right? It need not go all the way. It can be even a local loop. From here, it is coming, and the interpretation is happening locally on the edge. So again, we can clearly see this is a complexity wise smaller than Samsung Galaxy phone and iPhone and all that. So what are the components we have seen? We talked about the building blocks, right? So the microcontrollers, and then we have some edge intelligence. They're using GPUs, 8 GPU cards in their graphic cards, but it can be smaller ones. You can have custom processors. ST has, you know, a new device, and STM32 also has some embedded intelligence now in it. There are other people who are trying to do the same problem. Basically, everybody is trying to solve this problem. How do you bring more intelligence into the local decision making? When you see something, there itself we decide what to do without going to a big server and cloud and all that. In fact, even the robots now, they're carrying a Jetson pack, the smaller NVIDIA GPU for computing. This big Nano is even smaller, I think, this small it is. So those processors and the sensors, which are so many type of sensors, and then media, the imagers, and the processing that video and audio, sensing audio and you know, speech, and then the wireless communication. So these are the different components. But what are the technology involved here? What are the challenges people face? Is we have to create these in a very small form factor. Like morning, the Vice Chancellor was telling, these cannot be very large, and these have to be also very low power or no power. Maybe they can use harvested power. And also they have to be smart. They learn and see and try to do things with their intelligence. And then also these have to be very quickly prototyped, right? Because these conditions we are talking about, a phone is a phone, right? A phone use case, your quality of the camera is growing, right? You have a better camera, one front camera, one back camera, all these things. But predominantly, did you find a big revolution in the use cases in the last, let us say, 5-10 years in the phone? Then also you're taking photos, and we were taking videos, and we are browsing, we are doing WhatsApp, email, watching movies. Same thing we were doing 5 years back, right? So the use cases, the market is pretty stable. The use cases are stable. So you can, it is a market where you have to be with a lot of capital and lot of long-term planning. The use case is there waiting for you. But whatever we talked about, those use cases are evolving, right? If you talk about honeybees, maybe there is nothing like morning, you're asking, no, the Netherlands is number 2. Interestingly, the Delft, they have the Robo Valley. They have a place called Robo Valley. I have not seen in neither in Stanford or nowhere else. I saw in US also. These guys in TU Delft is a university near Amsterdam. They have a building called Robo Valley, reasonably sized building. Only robotic startups are there. You know what do they offer? They offer every evening, they have 2 hours program. If you run any business, if you are a dairy farm owner or you are a vegetable farm guy, whatever you are, you can go to their website, you can take an appointment, and maybe sir, you can offer the same in Kanpur, sir, or Noida. You can take an appointment, and all you have to do is you have to appear there, and very nominal thing, what they will do, they will understand what you are doing, and they will tell you how robotics can help you in your farm or business. No wonder now what you told, they told it's heavily automated. I did not go to see any farm in Netherlands, but this is what they told. I visited them. So these use cases are extremely different from what is in Netherlands, what is in a honeybee. Maybe we don't use honeybees in the same way in India, like you did your agriculture research, you are coming with a report. Maybe he will publish completely different use cases, which are not at all similar to what we have in Netherlands. So the fast prototyping, this is super important if you want to make a product in this type of markets where you are designing it. Again, morning the Vice Chancellor was telling, right, the embedded is a lot with custom application. So when it is a custom application, that means you have to be quick. You have to go there. Maybe it's a wrong problem also, right? Nothing is always correct. You go figure it out, and maybe it's wrong, you leave it, or you pivot and you solve some other problem. So it has to be super fast prototyping. And then the security. How do we make these devices talk to each other or talk to the cloud in a secure manner? That is another big challenge, because anybody can hack into those. Today, our security of these IoT devices is not very strong. In fact, even our phones and laptops and even their cyber security is a problem. Here it's a tougher problem. So these are the challenges which are to be solved. So now when we have to ask ourselves, what are the things one has to study or one has to prepare for a good job? So now you can tell me, in fact, I don't need to tell you, you have to learn how to connect sensors and control them from a microcontroller using Python or C program or something like that, so that you can sense the data of your wish, what you want to sense, and then do something about it. You process it, maybe intelligently, or if not intelligent, some basic processing. You don't use OpenCL or anything like that, but you use simpler processing techniques, and then you transmit this information. How do you transmit? to through internet using some whatever, some protocol, you send it over, and then you process it in the other side, which is pure software problem. Let's not go into there. And then when you receive something, you use transducers or whatever it is, and then do something about that information what you are getting. So this is the bare minimum learning one has to. The truth today is, in fact, Atul is telling, they went to IIT Delhi to recruit, right? They finally ended up recruiting only one person. They were thinking minimum 3 people. See, there is also a bias, which Sir was talking about, that there is a bias and how people learn things, the human angle, right? When we go to an interview, we are also working like a robot, other person is also working like a robot. Both are going through patterns only. We are trying to see in this 20 minutes, मेरे को दिख रहा है नहीं दिख रहा है. So उसको ये कुछ पूछ रहे हैं, somehow I'll answer and get this job. This is what we are doing. So we had done an experiment in BITS Pilani unknowingly. When we were going to the campus, you were telling, Saroj was telling, people were complaining that preparation is not good enough. We were telling Dr. Raghurama, who was our practice school, he was a placement head that time. Sir, people are not having fundamentals proper, that, this. Then he's very smart guy. Then he told Srikant, one thing you tell me, you take people for practice school, why are you offering most of them jobs? After end of 6 months of practice school in ST Micro, whoever comes from BITS Pilani, almost 80% are offered a job. Then how are you offering them the job? Can anybody tell what's different? When the same ST Micro is going to BITS Pilani to recruit people, giving only 2 offers or 3 offers, but when practice school 10 people are coming, they are offering 8. What is different? Can anyone tell? Experience. So these people have single-minded focus they kept for 6 months. So instead of 20-minute interview, they have 6-month interview. And what is the result? There is no need of interview. Correct? So because at the end of, it was very surprising. HR people also used to ask us, are you really sure you want to take these people? Say, yeah, we are very sure. So they used to ask us, you are not recruiting when you go to the campus. Now you take everybody whom I send. What is this? So the thing is to learn all these things, what was being discussed. Many people know, okay, to become a sportsman, you need to, we come to the engineering college. If we want to be very good, we have to study very well. But how many will really end up studying? The choice is made by very few people, right? So similarly, for getting a job also, what is required, what we just talked, sensor, microcontroller, C and Python integration, that is good enough. You do that and not forget, say, you go to Bosch, you go to anybody, they will give you a job. There's no doubt about it, right? So it is for you to be clear that this is what, that's where consciousness will help. So are we really conscious? I want to do this. Am I convinced? If I'm not convinced, unfortunately, we are a country where we choose things first for livelihood, right? Correct? Why we chose BTech? Correct? When I say we, means it's a lot of we. Uncle, auntie, daddy, mummy, no, all, right? What is the number one requirement? Right? Degree for. So now to become conscious and in third year feeling that, yeah, I should have become journalist, it's possible, but very difficult, dangerous, right? So try to make best out of this choice. Fortunately or unfortunately, now we are in the ITES winter, like AI winter. They were in 90s thinking that ये बंद हो जाएगा, बस 4-5 पेपर लिखने के बाद क्या करना है? No, we don't know where it is going. Same situation in traditional enterprise application development. We are also hiring, we are also doing this project, but I'm honestly telling you, the pure programming jobs which are only to make 5 screens, one for entering father's name and place of birth, another screen for entering grandfather's profession, those are over. Right? And these are the jobs where 300 offers in kits, 500 offers in SRM. So in newspapers, they give advertisements, right? These are all now not appearing because of other things like AI. The chatbots are already clearly proven technology. So most of the basic ITES jobs are gone. Before that itself, we had another AI who took away those jobs, Philippines, right? Because it's also clear, right? People, when they give jobs to Indian people, they were telling that before that number plate recognition was pakka in, learning based number plate recognition. All these toll booth number plates, images are sent to India. What Indian people will do, so-called ITES jobs with night shift, morning shift and all that, they'll be watching number plate by number plate and see the predicted number and correct the number if it is wrong. Because each ticket is probably $20, I don't know what, maybe. So this guy, that few minutes of this guy's time is few cents. So which is beneficial? This is beneficial, right? Now the AI algorithm is made it redundant. There's hardly any false negatives which are coming from this prediction. So those jobs are all gone. So today, whether we like it or not, our BTech degrees cannot give us those easygoing jobs anymore. So the only choice is this. Or you will end up with, institute. Some of you will end up in Java Institute. Some of you will end up in Verilog Institute with Deepak, Puneet. After a few years, we see some CVs even now we get. People who have done BTech in 2015, done some training, waited for some time, looking for jobs, all are 70%, 60%. I rarely see a CV with 40%. Have you ever seen a CV with 40%, 50%? Everybody is 70%, 60%. So please, pay attention to these things. So what can you do? Next steps. Next steps is tomorrow there is a workshop in the morning. First thing is about the software part, the C programming, how it can be done. And we'll also talk a little bit about what more you can learn just apart from basic programming by those, you can use any hardware, any software. It's a methodology which the team will tell. And the second workshop is going to be about the verification challenges. So I will not spend much time on, even though I put the title as, see, whenever you have a system like that, what is the challenge? You have to make it work now. Will anybody pay you if this doesn't work? The traffic is light, that will not sometimes go on, sometimes go off. Will you pay for that? No, right? So how do you verify that system? Using spice simulation. Maybe if it is a sensor, you have to use spice simulation. If it is a CMOS or a transistor level design, and if it is a chip with digital logic, what we have to do? You have to verify it using Verilog or system Verilog, or if it is a software, you have to use it using C++ or